Hi guys, so continuing off from our previous midterm prep video, we're going to be covering character functions. So let me get my pen, cross out some C syntax, and we're working on character functions. So I've kind of included a summary of everything we're going to cover and everything that is relevant to us. So we're going to be covering character functions from the cctype library, and kind of an overview from our previous video. We are right now going to be focusing on C++, okay, so we're currently in C++. Now without looking at that, let's declare the library we're going to be using. So hash include open cctype. Now from the name itself, there's a lot we can understand from this. So the C in the beginning of this library name denotes that this library comes from the language C, and if you hashtag include cctype, it's from this library which was originally in C. And we're trying to use this in C++, so we include the C in the beginning. Now the C type, the rest of it just stands for character type. And so this library has a lot of character checking functions we're going to be using. So kind of to go through these functions, character checking functions. So all these functions we essentially put in a character, a single character parameter, and we're going to check if it's true or false. So it'll return a bool type of true or false, but what's actually returned is a 0 or a non-zero value, and a 0 is understood to be false, non-zero is understood to be true. And so let's start with the basics. So is alpha? Is alpha, the name of it, syntax? We're going to pass in a character, and essentially it's just going to check if this character is true or false. Also, this is actually an incorrect form. Since we're doing a true and false, we typically want to assign a variable for this, so let's call it, I'll just call it variable. A bool variable, since we're returning a true or false. But also note, since we're returning 0 or non-zero, it could also be int. But bool is like an actual functionality we want of this function. So honestly, this is all quite intuitive, so let's just go through it, I guess. Is alpha, this function will essentially check if our values are between A to Z, or if it's between A to Z. Now if any of these are true, is alpha will return true. Now for our next character checking function, is digit. If it's from 0 to 9, is digit will return true. If not, it will return false. Is alnum. Okay, so this one is kind of interesting. I think the naming in like programming languages are quite intuitive, and I really like how things are named. So is alnum actually stands for alpha num. So is this character value either an alpha, so is it a value from A to Z or A to Z, or is it number? Is it a digit value from 0 to 9? So essentially this method is kind of a combination of both is alpha and is digit. So you don't need to use both functions to check, you can just use this method. And so it'll return a true if it's from one of these, else it'll return a false. Now for our next one is space. This one is also kind of interesting because you have to remember there are many ways a space can be represented in like many characters that represent a space. So if it's a white space, it will be true, but you kind of have to know what a definition of a white space. Now there are many characters which will fall under the definition of a white space. You can Google it and find them out, but more common ones, a new line character actually falls under white space. Also, it should be a backslant. It should be like this. A tab character actually falls under white space. And this space character, like the blank, obviously falls under white space. And there's a bunch more of them. So if this is true, it will return true. Now, kind of to skip over to another similar function is blank. Now, is blank, although blank is kind of blank is similar to the idea of a white space, this function is not the exact same of this, and this function actually only refers to two specific cases. Specifically, is it a blank? Like, is it a literal space? Or is it a tab? So it will literally check, is it one of these characters for is blank to be true? If it is, it's true. And now a third one, which is kind of similar. Well, let's go back in order, actually. I don't want to confuse you guys just yet. But yeah, so kind of no white spaces, blank. These two are kind of the ones that can get kind of tricky if you don't know your definitions of what a white space and this blank are. Okay, so the next one we're doing is lower, is upper easy. Just check, if it's lower, is it A to Z? Is upper, is it capital A to Z? Now, if those are true, then the function shall return true. Now, this one is X digit. Now, this one is quite interesting. So, is X digit essentially checks, is our character a hexadecimal digit? So this one you kind of need to know what values or hexadecimals represented through. So A to F capital, A to F lowercase, and 0 to 9. It's in one of these three categories, X decimal will be true. And to kind of remember it, is hexa kind of sounds like an X, and it has an X in the middle. So that's kind of one way you can remember it. Think of hexa, X, so like X digit, if you want to try that. Okay, now for our next one is essentially checks, is our character a punctuation? And so I personally don't advise sitting down and memorizing each of these individually. Just if it looks like a punctuation, like is it not a digit, is it not alphabet, like if this is something you'd consider a punctuation, put it. And also like through practice problems you'll realize, and like through experience you'll come to realize, hey, this is not a punctuation, stuff like that. But if it looks like a punctuation, it's probably a punctuation. Now the next one, this one kind of comes in pairs with is control, like polar pairs I should say. So is print essentially checks, is your character that you're checking, is it a printable character? Now printable essentially means like, does it visually exist? Can you visually see it like onto the console? Is it a character that you're just flat out putting to be seen visually? And so there's actually three categories I like to remember, or you can call it 4. Al-num. So all alphabets are going to be printable because they're just based on what you see. They are all visual, they're all printable. Same thing for digits. again based on what you see. We're just printing out literally onto the console. And then spaces as well. This space, I'm just seeing the space. It's all literal to me. And when I say space, I want you to think of specifically, because as I mentioned earlier, we can have white spaces, we can have blank spaces. So for this definition, I would think of just the space character, like simply just the space character. And also, last but not least, punctuation. So think of these three, and for the space character, we're only going to think about one space character. And now, the next function we get, which is polar, or I should say anti-opposite, well, is control. So is this a control character? So is control, basically we're checking, is it a non-printable character? And control characters kind of work with the cursor. So all of these are not, all of these are printable, so they are not control characters. Now, characters like a new line character, it's not printable, so it is a control character. And character, a tab, this is not really intuitive, is actually also a control character. And also no is also a control character. Now kind of to go further into why are these control characters? So control, the way I like to think about it, is control dealing with the actual cursor of the mouse, like where it's pointing to. We're controlling this cursor around. So when you use a new line character, what you're actually doing is you're moving your cursor from the line it is on to the next line. Thus, it's a control character. You control the cursor with your new line. It's also non-printable. You don't visually see it. Now, the thing about tab, it seems to be printable. Like you visually, when you print out a tab, like you put the word cat and you put in the character tab, you will get a tab of space. And so visually, it looks like a printable character, but it's not a bunch of spaces that are getting printed out. What's happening is actually the cursor is being moved a tabbed length away, so it's actually a control character. So even though visually it looks like you're printing out spaces, it's non-printable. What's happening is the cursor is moving. And then this one should be intuitive. You get nothing output with this character. So non-printable. And so something else I kind of want to make mention of is printable and is control are not quite equal opposites. So like all possible characters you can have. So if all possible characters was a pool, you won't actually get like a 50-50. Like you won't like get 50 characters. Not 50-50, but you won't get like a character is either a printable character or a non-printable character. We actually see that we'll have a third quantity, and also just because I put 3 box doesn't mean like the ratio. Oh, there's 33.3% printables, 33% this. No, I'm just trying to illustrate the idea that printable characters exist. I should use the other structure. The Venn diagram. So a bunch of circles. And then together we get our combined set. So we can get printable characters. We can get non-printable characters. And when I say non-printable, I mean like control, stuff that specifically controls the cursor. And then we can get characters that are neither printable nor control. And you might think, what's not printable and what's not printable and what's not control. So a good example is the quotation character. We literally use the quotation character when we're writing out codes. So like C out quotation. It's neither a quotation mark is neither an alphabet, it's neither a digit, it's neither space, and it's actually not a punctuation. Okay, and it's also not dealing with the it's also not dealing with non-printables. Also, I just realized over here I mentioned if printable, and I said it's punctuation, and I said quotation was a quotation was a punctuation. Well, yes, a quotation is actually a punctuation, but don't think of this punctuation. Okay, I shouldn't have said punctuation, my bad. I should like indicate here some punctuation. Not all punctuations are printable, so kind of keep that in mind. And so we get that. And then after all our character checking functions, we also have character conversion functions, where essentially you'll put in a character and you'll output a character as well. So to upper, like the name implies, if you put in a character C that is an alphabet from A to Z or alphabet A to Z, it will output the uppercase. So if you put in the lowercase, you will get uppercase value. That's from A to Z. And if you put in an uppercase here, it will leave it unchanged. And also something else to know, if you accidentally put in a 1 or a 9, if you put it in, it will accept. However, it will just output a 1 and 9. It won't change it. So it accounts for that. And a two lower method works exactly the same, except it will make it a lowercase if it's an uppercase. And if you enter any other character, since it accepts all character data types, it will leave it constant. It will leave it unchanged if it's not able to lower it. Okay, so that's essentially everything dealing with character functions. Now we could go through a couple of examples in the next video. I'll try to kind of go through this again, but like on the compiler. Thank you for watching. Let me know if you have any questions in the comments.